Hey everyone, we went over ellipses and hyperbolas in class this week, so I wanted to take a look at some application problems of both of those conic sections. So we'll go ahead and start with the ellipse, and here's the first problem. This is directly from your notes. It says a semi-elliptical archway over a one-way road has a height of 10 feet and a width of 40 feet. Your truck has a width of 10 feet and a height of 9 feet. Will your truck clear the opening of the archway? So it's really important to make sure that you draw an accurate picture before you start doing any of the math behind the problem. So if we were to go ahead and draw an elliptical archway. So here's my archway. Here's the road. There's my archway. And it says it's a one-way road, which means that my truck is going to go right down the middle of the road. So let's go ahead and represent kind of the middle here. We'll do a dotted line. So if you kind of think of this as like the middle of the road, so to speak. Okay, so what information do I know? I know that the width of the archway is 40 feet. So from here all the way over to here is 40 feet. Right, that distance is 40. Which tells me, and what else do I know? That the height of my archway is 10 feet, right? So this height here is 10. Okay, so that's the information I have. So if we think of right here where the horizontal meets that vertical, which is the center of my arch, if I consider this to be my origin, right, I have a little bit of information. I know the coordinates of this point. I know that that's 0, 10. I know the coordinates of this point are 20, 0, and the coordinates of this point are negative 20, 0. So I can go ahead and write the equation of the ellipse, right? This is just an ellipse centered at the origin with an a value of 20 and a b value of 10. So if I were to go ahead and just write out that equation, I would have x squared over 20 squared plus y squared over 10 squared is equal to 1. So that gives me x squared over 400 plus y squared over 100 is equal to 1. So there's my setup. Now, I have a truck that has a width of 10 feet and a height of 9. So my truck is going to go right under the middle of this bridge, right, because it's a one-way road. So I'm not the best truck drawer, but if you're kind of looking at the truck right from the back of the truck, right there's my truck. Here are the wheels on my truck. Right, that's kind of like the back of the truck, okay? And what I'm trying to determine, will my truck clear the opening of the archway? If my truck has a width of 10 feet, that means from here out to here, this is 5 feet, right? So I'm trying to figure out the height of the archway at that point 5 feet from that vertical. Right, so basically what I'm trying to figure out is when x is equal to 5, what is y? What is the height of the archway? So I know the x-coordinate of this point is 5, comma something. I just don't know what it is. So I'm going to figure out what y is using my equation. If y happens to be greater than 9, and I know my truck will fit, right, because my truck is only 9 feet tall. If y happens to be less than 9, that means the archway isn't even 9 feet tall at that point, which means my truck won't fit. But I have the equation, and I have an x value, so I can plug that x value in. I can plug 5 in for x, and then just solve this equation for y. So if I plug that in, I have got 5 squared over 400 plus y squared over 100 is equal to 1. If I kind of combine a couple of steps at once here, I end up with y squared over 100 is equal to 1 minus 25 over 400. Right, so I just moved that fraction over to the other side. And if you think of 1 as 400 over 400, I'm doing 400 minus 25 over 400, so that gives me 375 over 400. Right, which then gives me y squared is 375 over 4 if I multiply both sides. I multiply both sides here by 100. And I end up with 375 over 4, which gives me a y value when I take the square root of both sides. That gives me y is approximately 9.68 feet. So that means the archway, 5 feet from the center of the archway, the height of the archway is 9.68 feet. And since my truck has a height of 9 feet, my truck is going to fit. So, yes, my truck will fit. Okay? So again, draw a picture to lay out the problem so you can see what's going on. And from there, you have your equation for that particular ellipse, and then you can plug in the information you have and find your missing value that you need. That's one example of an application problem with an ellipse. Here's another example. We talked a little bit about this in class, and we said that a whispering room is one with an elliptically arched ceiling. So if someone stands at one focus of the ellipse and whispers something to his friend who's at the other focus, the dispersed sound waves are reflected by the ceiling and concentrated at the other focus, allowing his friend to clearly hear what he said. So, let's suppose such a gallery has a ceiling reaching 20 feet above the 5-foot-high vertical walls at its tallest point. Okay, so the cross-section is half an ellipse topping 2 vertical lines at either end. So here's the idea. If I have this and this right here, right, and here's my ellipse. Okay, so this height is 5, this height is 5. And that's my ellipse. That's like the ceiling of the room. Okay, and my foci, right, are kind of going to be somewhere like right around here and right around here. Right, those are my foci. So the question says, suppose such a gallery has a ceiling reaching 20 feet above the 5-foot vertical walls at its tallest point. And suppose the foci of the ellipse are 30 feet apart. What is the height of the ceiling above each whispering point? So what we're looking to find, right, is this height here. Right? That's what we're looking to find, the height. So let's actually do the height of the ceiling, so all the way from the floor there. That's what we're trying to find. Okay, if I were to kind of take this ellipse and kind of draw in the whole thing, right, I would end up with something that looks like this. Right, if I was looking at the cross section, right, I end up with an ellipse that is, it's going to be a really bad drawing, but you get something kind of, whoops, right, this would be my whole ellipse. Really badly drawn. But there's my whole ellipse. Okay, the center of my ellipse, let's see, is 25 feet above 5 feet high vertical walls. Right, so the center of my ellipse is not at the origin. The center of my ellipse is here up at 0, 5. Right, that's the center of my ellipse. Okay, and I know the distance between the foci are 30 feet. If the distance between the foci is 30 feet, then the distance from the center to one foci is 15 feet. Right, so I know a couple pieces of information. I know that C is 15. I also know that my B value here is 20 because the height of my ceiling above at the highest point there is 20. Okay, so I know that B is 20. So I can use my formula C squared is equal to a squared minus b squared. I have 15 squared is a squared minus 20 squared. And that gives me 225 is a squared minus 400. A squared is 625. And so a comes out to be 25. Okay, so remember a is the distance from the center to the end of the major axis, right? So this distance here out to here, that distance is 25. Okay, so I know what b is, I know what a is, I know what the center is, so I can go ahead and write the equation of my ellipse. Remember, I'm using the form x minus h squared over a squared because this is a left-right ellipse. Y minus k squared over b squared is 1. And I can go ahead and plug the values in that I know. So my center is at 0, 5. So I have x minus 0 squared over 20 over a squared, which is 625. And I have y minus 5 squared over 400 is equal to 1. That is the equation of the ellipse. So now what I'm going to do, it says, what is the height of the ceiling above each whispering point? I'm trying to find, right, the coordinates of one of these. Right, I'm trying to find the y coordinate of that point. I know this is 5. Sorry, I know this is 15 because it's 15 from where the center is, right? That distance is 15. So I know the x-coordinate is 15, and I'm trying to find the y-coordinate. Okay, so I've got 15 minus 0 would be 15 squared over 625 plus y minus 5 squared over 400 is equal to 1. And from here on in, it's really just algebra. So I have y minus 5 squared over 400 is equal to 1 minus 225 over 625. So I'm just going to go up here. I have y minus 5 squared over 400 is equal to 400 over 625. I end up with y minus 5 squared. When I multiply both sides by 400, I end up with 256 here. I'm not going to do that in the calculator. I think you guys can handle that yourself. Right, so I end up with y minus 5 is equal to plus or minus 16. And so y comes out to be 16 plus 5, which should be 21 feet. So the height of the ceiling above each whispering point is 21 feet. Now that might be a tiny bit misleading when you see that the ceiling reaches 20 feet above the 5-foot-high vertical walls, right? That's why the distance from the center here up to the top was 20. It wasn't from the floor up to the top. It was from here up to the top was 20. But the distance from the floor to the ceiling here is 21. So that is, those are a few examples of some application problems with ellipses. In the next video, I'll go through example problems, application problems with hyperbolas.